Hi, in this lesson we are going to look at Java numeric promotion. Okay, in the main method I have created variables for all the 6 data types: byte, short, int, long, float and double. Okay, so here I am creating 3 variables: boolean value 1, sorry not boolean, byte value 1, byte value 2 and byte value 3. If you see here, this is a integer literal as we know, and compiler is allowing us to assign a integer to the byte because the value is within the limitations of the byte. So here also compiler is letting us assign 1 plus 2, 1 plus 1, that is 2, to a byte variable. If we do the same thing with variables, for example, if I uncomment this, so we are basically doing the same thing, right? Byte value of 1 is 1, byte value of 2 is 1. So the value will be 2. But compiler is not allowing us to do that. Why? Because here the compiler knows that the result is 2, it is an integer. So, but because 2 is within the byte range, it is letting you assign. But here you are adding 2 bytes. So we may think that the result of adding 2 bytes is going to be a byte, but that is not the case. At runtime, these will be promoted to integers. Basically this byte value 1, that is 1, will be promoted to integer. This is also going to get promoted to integer. So at the value of this expression, like value 1 plus value 2, will be known only at the runtime. So the compiler cannot promise you that okay, the value is going to be 2, so it can be accommodated in this one. It's not the case. Whatever the value at the runtime, the compiler doesn't know. So compiler can't help us here. So if we know that the expression value is going to be within the byte range, then we have to explicitly cast it to byte, because integer cannot be assigned to byte. Let's do the casting by providing byte. Okay, it is still complaining. Why is so? Because this byte, the cast expression, has lower precedence over this summation or addition. So what we have to do is we have to include this expression inside parenthesis. So what happens is these will be promoted to integer, the sum will be evaluated, the integer value will be converted to byte before assigning to a byte variable. Okay, so this is how we have to write. Okay, so there is another simple way to write this one. Actually, if this variable is same as this one, for example, byte 1 value we want to increase by the amount of byte 2 value 2, then we can write it as byte value 1 plus equal to, that is a combined assignment, right? Compound assignment, sorry. Yeah, so we want to increase by value 2. So here there is a addition happening, addition of value 1 plus value 2, nothing but this one, and after that it is again being casted to byte, whatever is the type of the left hand variable. So this can be expanded to this one. So that's what I have mentioned when we were doing when we were discussing the compound assignment. So this is what it is. So instead of doing this summation then converting to byte, we can simply use the compound assignment. Okay, let's look at a different example. For example, we have to increase value 3 by 1. So here same thing is happening, because 1 is an integer, this will be promoted to integer, and the summation is the value of the expression is integer cannot be assigned to byte. So obviously we have to include this inside parenthesis, then we have to cast it to byte. Instead of doing this, what we can do is this should work. So what happens is the value of byte 3 will be increased by 1. So these are our friends. Instead of writing this much long expression, we can simply write this. Instead of writing this one, we can simply write it. Okay, that is all about integer promotion. But let's look at when other primitive types are involved. For example, Here if we are adding double with long, the resulting type is double. If you can see the error message here, it is saying double to int, right? I mean because here what is happening is, if any of the operand is double, the other one will be automatically converted to double. So we can only assign it to double value, otherwise we have to cast it explicitly. And coming to the next expression, if we add float and long, then the resulting value will be of the type float. So we can assign it to only float variable, otherwise we have to cast it to another type. Similarly, if we are adding long with anything, so the resulting value will be long. So you can clearly see that in error message. So we have to assign it to long. Okay. So is the case with bytes. Already we have seen byte plus byte. Anything will be converted to integer. Int plus short also will be converted to integer. Okay. So here is what we have learned in this lesson. Actually, this is the order. If either operand is of type double, the other is converted to double, the result will be of the type double. Otherwise, meaning none of the two operands are double. In that case, if either operand is float, then we convert the other one to float and the result will be float. If that is also not the case, we will go to the next one. If either of operand is long, then we will convert the other one to long. If that is not the case, we will go to the last one. Both operands are converted to integer. So these are the only possible scenarios. Okay, there are no other. Either it will be double if any of them is double. It will be float if any of them is float but none of them are double. It will be long if any of them is long but none of them are float and none of them are double. In all other scenarios, it is going to be int. So this is a very simple lesson, easy to remember. Please try some combinations and see for yourself. Also, please remember, these are the two expressions that will do the implicit typecasting to the target type. Thank you for watching. Please subscribe and share it with others. Thank you.